Hey everybody, Jessica Danella here, Cub Scout Roundtable Commissioner for Pioneer District with New Birth of Freedom Council. And today we're going to be doing 2 science experiments. So while my son's heating up water, I'm going to go over the list, or materials list that you're going to need for these two experiments. First experiment is we're going to be working with glow sticks. If you guys don't have glow sticks, Dollar Tree has a pack of 4. Get 2 of them because you want the same color. So when we crack these should be green, but that part doesn't really matter as far as what color they are, as long as it's 2 glow sticks of the same color. I know the pack of 4 comes with like blue, red, green, and purple, I think it is. But again, it doesn't matter as long as you have 2 glow sticks of the same color. You need 3 cups. So my son has the warm water. This is cold water. You're going to need a cup of like medium to hot water, but not boiling. You don't want it super, super hot, but enough, lightly, I'd say lightly warmish hot so your Cub Scout can still stick your finger in it. And then your second experiment, you're going to need another cup, bottled water, and salt, and a hard-boiled egg. So, let's get this started. Alrighty, so my son is back.
Hi.
He's my Wolf Scout. His name is Hunter.
Hello.
So we're going to take our 2 glow sticks. We're going to crack them. Shake them until the light comes on. What? You can't crack your...
Oh my god. I can do it. Stop.
Come on, camera. Maybe.
Oh my god. I got it.
He's having a little bit of an issue. What are you doing? You have
to crack it.
Here. I'm going to hold one side. You hold the other.
Oh my god.
Ready?
What?
Hold it. Go.
Oh my god.
It doesn't want to crack. Ah, there we go.
Shake
it until the light comes on.
Ah! My
So
eye
these are
is
green. Okay.
My eye is green.
Yeah. So we're going to take our 2. And the reason why we're doing this first is so
it takes the longest.
It has the longest time frame as far as you want to do this. So this water is cold. This water is like lukewarm hot. Okay, that's enough. So we're going to drop them in at the same time. But first, we're going to talk about scientific experiments. Okay, so we have our hypothesis, right? We have our variables, so hot and cold. They're not the same. And then we have our conclusion. Okay, so my hypothesis is that the cold water is going to make the light brighter.
Yeah.
But what's your hypothesis?
I think the hot one, because it's gonna...
Just say why. Don't say because. Just say what your hypothesis is. I think the hot water is going to be making the light brighter.
No, I think the hot water is going to make it longer.
Well, it's brightness.
Oh, the hot one's going to make it more brighter.
Okay. So, again, my hypothesis is that the cold water is going to make it turn brighter, and he thinks the hot water is going to. So, at the same time, we're going to drop them in, and then we're going to let them go. Okay, ready? Go. Okay, so we're going to set this up to the side.
That one's dimmer.
It's okay. Not yet. We got to wait a little bit. We got to wait a couple minutes. Okay, we're going to let those sit for a little bit. I'd say about 5-10 minutes. We're going to be looking at them beforehand. Second experiment is you're going to need, again, hard-boiled egg, salt,
and a cup,
water, or cup, and water. So Hunter, while I hold the hard-boiled egg, please open that without bumping the other cups and pour it to maybe about halfway. That way you want to make sure it's not full up to the top, so you have more room to pour more water into it. Maybe. That's good. That's good.
I barely have any water.
So I'm going to do this just so it doesn't plop down.
I can do it.
Just regular water. My hypothesis is that it's going to float. What's your hypothesis?
I think it's gonna sink.
With just regular water?
Yeah.
And you think the opposite for the salt?
Yes.
Okay.
No. I think the salt is gonna make it float.
Okay. So what about just regular water?
Regular water, it's gonna sink.
Okay. So I think the opposite. I think the salt water is gonna make it sink, and the regular water is gonna make it float. So we're gonna see. And again, this is a hard-boiled egg. Oh, I was wrong. Hunter was right.
That looks so big.
So, this is
So
where the
big.
experiment comes in.
I'm gonna put this salt.
Without bumping the table. He's gonna shake some salt
How
in
much?
it and see what it does. Do it until something happens. Careful.
Hold on.
Don't poke. What's it doing?
Dude, nothing's happening.
Nothing?
Wait, it's kind of floating. Kind of.
Hold on.
I need to take this top off.
This is a really...
No help. Oh,
What's it doing?
nothing. It's moving.
Okay, let's wait.
It's moving. It's not floating though.
It's not floating at all?
No,
Nothing?
no. I think you have to have the like we would have to refill that with
I
salt.
don't think so.
That's tons of salt.
That is a lot of salt.
What are you doing?
Making sure that it's not stuck.
Probably is stuck.
No, it's not stuck.
It's not moving.
It's not doing nothing.
I think we need to add more water. We need to add more water.
You think?
Yeah.
Okay, well, we're gonna try this.
Sorry, add the
Not really sure how much salt we're supposed to add, but it's okay.
Oh! Dang it! It moved.
It's okay.
It moved but sunk.
It's okay. Can you go refill that worth of water, please? And get more salt. Alright, so what I'm going to do, just for giggles, I'm going to stir the salt water, see what it does. But obviously, when it was sitting on the bottom, it wasn't doing anything. So, let's... It floats!
No, wait.
It's there. It's floating.
But we have to get in the middle though.
It's okay.
That's the issue. Are you adding so much? Now it's sinking. It's just sunk.
Is it sinking?
Yeah, it just sunk. Literally, it just sunk. It's right there.
Trying not to break the egg.
You gotta have more salt.
So with this science experiment,
More salt?
you should have a floating egg. Okay.
It is technically is floating.
So, yes, it is floating. Right now, it's somewhat in the middle. So your job at home as scouts, you want to add more water. The water to salt content ratio will differ. And what it'll do is it'll make the egg sink, or it should. Obviously, ours failed. Stop it, Hunter, please. Thank you.
Squishing them into the middle.
The egg will go down to sink, and the more salt you add, it will rise back up. Your job for this science experiment is try to make it hover. Try to get that salt to water ratio correct to where it hovers right in the middle. So, looking back on our hypothesis, mine was wrong. Based on the actual science experiment working. Ours obviously didn't work. Stop with the salt, please.
That's not doing anything.
But at home,
Wait,
your
hover-
cup could be bigger, what have you. Ours is, kind of narrow, so I don't know if that made a
There's
difference.
salt on the bottom.
But I don't know. Your job is to make it hover. Okay, so we're going to look back at our glow sticks. Again, this is cold, this is hot. You guys get to tell me, and Hunter, you, since you're here, get to tell me which one's brighter. Whose hypothesis was right? So again, this is cold, this
one's
is hot.
hotter. This one's lighter.
So why do you think, Hunter, that the hot water, because you were right, your hypothesis was right.
On both.
Why do you think that that your hypothesis of the hot water, warm water, making the light brighter, why do you think that was correct?
It's cause
You don't know? Well, if he was paying attention yesterday during the class he was looking at, the hot water makes it brighter because of the chemicals inside of the glow stick.
it's meant to be hot.
No, it's meant to be cold. So that's why when you stick a glow stick in your freezer, even after it's broken, the light dims really, really, really low to last a lot longer. This may be brighter, but it's going to burn out a lot quicker than the cold one. Because when you think about it, when you break a glow stick, it's what? It's cold.
Bright.
It's cold.
Yeah, and cold.
When you hold it, it's cold. So go grab another glow stick.
What color?
I'll show you.
What color?
Any color, doesn't matter.
Where are they?
Oh, I put them back in the bag, sorry. So when you break a glow stick, hold on. When you break a glow stick, it is naturally kind of cold. It's not warm, it's not hot to the touch or anything like that. Hunter wants to say something.
What color should we use? What color should we use? Should we use blue, green, pink, or orange?
Well, we already used green, so let's do blue.
Okay.
Because the sea creatures in the ocean, you think of the mid-layer or the mid.
What the heck is this? What's
That's
this?
blue.
Is
If
it
you
blue?
think of the mid-layer of the ocean and the deepest part of the ocean where it's just about black.
Can I crack it?
Hold on. The bioluminescence is blue. Red only goes so far when you're diving into the ocean. It only goes so far to your natural eye, but blue you can see really far away. So he's gonna crack a glow stick. Hopefully he can crack this one. Maybe.
I'm not break it.
You're not gonna break it.
I'm not puncture it.
Let me try.
I got it.
Put your thumbs in the middle.
Done.
Maybe.
Oh my god.
These glow sticks, for whatever reason, are really hard to break. Let me see.
They're not thin. Oh my god.
Ready?
How can you crack them so easy? That's purple.
So this bioluminescence inside, if you're, let's say you're a diver in the ocean, you're going to see this a lot further than you would red bioluminescence. So when it comes to this science experiment, you can even see now because it's been a little bit more. This is dimmer. This is a dimmer bioluminescence than the hot one.
See?
So in conclusion, Hunter was right. The hot one is going to make it brighter, but it's also going to die out a lot faster.
Is it really?
Yes. This one, because it's super, super bright now. This is going to last maybe only
2 minutes.
No, it'll last maybe
5 minutes.
8 hours compared to this one that may last 24 hours because it's being cold. So feel it.
That feels cold.
See how it's not hot?
Yeah, it feels hot.
Now, if you hold it in your hand, obviously it's going to get warm. But to the touch, it's not hot. It's not warm. It's not
cold.
Lukewarm. It's it's not ice cold, but it's cold to the touch.
Sort of cold.
Yeah, there you go. But those are our 2 science experiments. Again, all you need is 3 cups, unless you want to reuse one of them for this experiment. But to be able to do all of it at the same time, you need 3 cups. You need water for this experiment right here. You need hot water or not boiling hot water, and cold water. You need salt for the egg, hard-boiled egg, and me personally, I used a spoon. So that and the glow sticks, obviously. You want 2 of the same color. We are still using Scouting at Home hashtag for being able to find these videos on YouTube. Scout Hub, it's the second link at newbirthoffreedom.org. We are also on Facebook at New Birth of Freedom Council, BSA, or Boy Scouts, excuse me. I keep getting that wrong every time. But these are our 2 science experiments, and they stem from a marine biology and oceanography, whatever you want to call it. I'm not the best at saying and pronunciations, but
I'm not either.
Oceanography class that we took yesterday during this Scouting at Home time. So credit to that. These 2 experiments were in the presentation. So I was really excited to be able to share this with you guys today. I hope you guys stay safe, wash your hands, social distance, and enjoy these 2 science experiments. Bye, guys.